Hello, everybody. Welcome to Lowell Observatory. My name is Claire, and I'm an educator here. And welcome to the third interactive stargazing. So I'll walk you through a little bit about what we're going to be doing tonight if you're new here. So we'll be looking at many different objects in the night sky tonight live for you guys. So what we are using is our 14-inch Planewave CDK telescope. So it's not like a regular telescope. Instead, it takes pictures of the night sky. So we're going to be taking in requests from the live chat that you can see on your guys' YouTube screen. So if you guys have any requests for us, we'd be happy to take them. And I'll lead you through each object that we're going to talk about. So we have one already up. We are looking at the Southern Pinwheel right now. This one is also known as M99 or the Coma Pinwheel. I think it's right around the constellation Coma Berenices. But this is a pretty nice galaxy that we have to start with. So this is a spiral galaxy. You can even start to see some of those arms of the spiral galaxy. You can see that nice bright galactic bulge right there. And again, galaxies are just going to be these regular type big blobs of gas, dust, stars in space, all held together by gravity. If you look right there, I believe a satellite passed through, so sometimes we'll get that where we can track some of these satellites. That's what some of these streaks mean that you can see going along your screen. So sometimes that will happen, and that's what that means. So if any of you guys have any requests, keep bringing them in, but for starters, I'd like to show you guys that one of my favorites. We're going to go ahead and go to M81, which will be Bode's galaxy. Or Bode's Nebula, it's also called. So if you look up at your screen, you'll also be able to see the telescope slewing, which means that that telescope is moving from one point to another. So slewing means it's moving, basically. And it looks like we're taking a 15-second exposure here. So kind of how this works, just to walk you through this, we're going to be moving the telescope. We're going to be changing the exposure, changing the gain or the sensitivity. We'll also be tweaking some other type of instruments along the camera so we can get the best image that we can possibly get you guys in the shortest amount of time. So that's what's really fun about this, is that we can show you guys so many different things and have some really great quality pictures. So here it is. It's a very bright one. It is one of the brightest galaxies that we can see in the night sky. You can see it from smaller telescopes as well. It's a great one to look at. And because it is so bright, it's a little bit hard to see the spiral arms of this galaxy, but it is a spiral galaxy, this one. And again, it's called Bode's galaxy. So for the spring sky, they're going, nice. Now we can see some of those arms going up and along right there. You can see them kind of twirling around that nice bright galactic center. So this is a pretty nice one. Again, it's one of the brightest ones that we have, so you can see that nice bright galactic bulge really, really well. But for the spring sky, we're not quite into summer yet, which means that we're going to be looking at a lot of galaxies in the forefront, I'm assuming. But later tonight, we can get to some of the more exciting nebula type stuff as the sky begins to rise a little bit for some of that nebula. So we're going to move pretty close from M81 into M82. M82 is called the Cigar Galaxy. It is really, really close to Bode's galaxy or Bode's nebula. They're actually neighbors, kind of. So we'll wait to get that started. So what you're viewing right here is our Planewave software. This is how we find objects. We kind of just say, hey, telescope, go to this object. It'll move itself automatically, and we'll start getting that image in. So as we move around, you might be able to see some of these streaks coming off some of these stars. What that means is that we haven't stopped the exposure. So as we move the telescope, it's still taking in some of that light. So it'll kind of move these stars around a little bit. So it might take a couple cycles of the exposure time for us to get a really nice image. Alrighty, coming in here. Nice. So as you guys can see, it is quite a different type view of galaxy. So we're going to take the exposure down a little bit just so we can try to get some more detail in and around those dust lanes to not make it quite so bright for us. But this one's more of an edge-on view, which is quite different from what we viewed with M81. Now, the really interesting thing about this galaxy is that it is a starburst galaxy. So we classify this as an irregular galaxy. Nice. So we can start to see some of those details with the dust coming in and around that nice bright galactic bulge. So the starburst galaxy is irregular, and we think this irregularity is triggered by the nearby M81 galaxy via gravity. It's kind of making it do some weird things. So it's not a traditional galaxy in the sense that it's going to be elliptical or spiral. Instead, we call it an irregular galaxy, and this one in specific is the starburst. And a really cool thing about this one, as you can already see, it's very, very bright. It is 5 times more luminous than the Milky Way. So it's one of the brightest galaxies that we are able to see fairly close to us in the night sky. M81 and M82 both together make up the M81 group, and it's one of the closest group to our own local group of galaxies. So galaxies cluster together in these groups. So with our own, we have the Milky Way, the Andromeda, and the Triangulum galaxy, among many, many dwarf galaxies. So we cluster in this group. M81 and M82, among others, cluster into another group, and both of these, plus a bunch of other groups like our own, all combined to create the Virgo supercluster. So we're part of the Virgo supercluster. So it's this giant cluster of galaxies. So we'll be looking at some star clusters tonight. Let's go ahead and move to one of them, actually, just for fun. Let's go ahead and move to M4. That one was looking pretty good when we were looking at it earlier. So we're going to be looking at a globular cluster. Now, if you can imagine a globular cluster, but with galaxies, that's kind of what it's like. So there's going to be a bunch of galaxies around in a galaxy cluster, but a globular cluster is a bunch of stars, nice and compact together. So waiting for this image to get in. We're almost there. There we go. Starting to get a nice, really nice and crisp image. So you can see right in the center that we have quite a lot of stars all packed together, and as we move out, they kind of become a little bit farther apart. This is a really nice cluster that we can see here. Nice. One of my favorite things about star clusters like this is whenever guests come up to Lowell Observatory, I always like to ask them, hey, what does this look like to you? And I get some of the really cool answers. Some of my favorite is, it looks like a frozen firework, or it looks like raindrops sprinkled on a spider's web. Or I've even heard someone, it kind of looks like powdered sugar dusted on a black sheet of paper, and I've never heard of that. And so it's really fun to hear some of the guests say what they think a star cluster like this looks like. So if you guys have any cool ideas, put them in the chat. We'd love to hear what you think about what a star cluster looks like. And again, keep those recommendations coming in. We'd love to find objects that you guys are excited about seeing as well. So here's a nice cluster that we have. So let's move on. Like I said, we're going to have a lot of galaxies tonight. So let's go to M104. M104 is going to be what we call the Sombrero Galaxy. There we go. So we'll see the telescope moving again. It moves super fast. Here at Lowell Observatory, we call it the Ninja Telescope because it's also silent. It kind of sneaks up on you in terms of it moving. Kind of have to watch your head sometimes, but it's a great one. So let's take a look at this one. This is one of my favorite galaxies to look at. We'll be tweaking some of the, or upping the exposure to get some more of that detail. See what it looks like. So you guys can keep track of the exposure time with us as well. If you look down to the very bottom of the screen right in the center, you'll see this little bar that says exposure, and it'll tell you how many seconds are left in our exposure time. So you guys can keep track with us with that as well. So the Sombrero Galaxy, it's a nice edge-on galaxy. You can see that nice dark dust lane right in the center. You can also see that bulge coming up and across as well. Now, the Sombrero is also an interesting galaxy. We call it an armless spiral galaxy. So it has a nice bright central bulge, as you can see. There's not really any spiral arms. So it creates a kind of galaxy shape, except there's not really any distinct spiral arms like some of the other galaxies we already looked at. It has a really nice bright central bulge that we can see. Now, this galaxy is also close to home for Lowell Observatory. This was one of the galaxies our second director, Vesto Slifer, looked at with a spectrograph. He found that this galaxy was doing some pretty weird things in the night sky. He found that A, it was moving pretty fast, and B, it was moving pretty fast by the Doppler shift. So if we look at the Andromeda galaxy in the night sky, with the Doppler shift, it'll be moving towards us, which means that it is blue shifted. When it's coming towards us, it means it'll be shifted towards the blue. If you can imagine a rainbow, that light will be shifted towards the blue end. If a galaxy is moving away from us, it'll be shifted towards the red. So Vesto Slifer noticed some of this stuff with many of the galaxies, or what we then knew them as nebulas back then. And it was some of the first evidence that we used for the expanding universe that Edwin Hubble came up with in the 1920s. So Vesto Slifer is usually coined as a co-discoverer for the expanding universe, which is really, really cool. That's one of the cornerstones of cosmology today still, which is pretty awesome. So it looks like we have a request from Comet Pan-STARRS. We can do that. So let's go ahead and get to that. We have the coordinates all set up because we figured one of you guys would really want to look at it. It is quite a sight to see a comet. So what you're looking at here is what we call RA and dec, or right ascension and declination, which is basically the coordinates of the night sky. So just like we have coordinates down here on Earth in order to know where we are, we also have coordinates for the night sky so we can find things in the night sky pretty easily. So we're just entering the coordinates for this comet for today's night sky. I'm gonna take a look, and it'll bring us out there soon. Sweet. So we're waiting for that exposure to change again. We're almost there. We're starting to get it. Nice. Just a bit. We'll wait for one more cycle of exposure, but we're going to be looking at a comet. So this is one of the comets that are viewable right now. It's also a pretty bright comet, which is really lucky for us. Sometimes it's hard to find comets in the night sky because they're really faint. Here we go. Nice bright in the center. So you can see that nice bright part of a comet right there. So comets are pretty interesting things in our own solar system and probably in other solar systems as well. But comets are kind of like these giant snowballs that orbit the sun, and some of that like snowy, dusty, dirty type stuff, there's even little bits of rocks in comets. They come off of that comet, and some of them create meteor showers here on Earth. So most of the meteor showers that we have are actually created by comets, which is really cool, something that you probably wouldn't even expect in the first place. So again, comets orbit the sun at a regular pace, and we also get those meteor showers at a regular pace as well. So it kind of makes sense for that. So again, here's that nice bright comet in the center. Keep your requests coming if you have any. There are many, many galaxies up, and in a little bit, we'll be able to look at some of the more interesting type of nebula as well. It looks like we might be able to try the Swan Nebula right now. So let's go ahead and try that, just for a change of scenery. The Swan Nebula is one of my favorites. So we can get it in. It's actually a nice, bright, diffuse nebula, and it's going to be close to the constellation Sagittarius. So we'll wait for that to get in. Looks like we're going to be lessening our exposure time again, because this is a really, really bright nebula that we can see here, so we don't need quite as much light collecting time, basically. So we can do that to get the best image for you guys. There we go. Starting to get in there. So it's upside down right now, but you can see that the swan's head is curving down on the bottom, and its body kind of goes up diagonally to the left-hand side. So it's an upside down swan, but if you can imagine it, it does look quite a lot like a swan. I can actually draw it for you guys. Hold on one sec. So here's kind of like the head of the swan right here, and the body is going to be right here. So I know it's kind of upside down right now, but if you can imagine it, it looks pretty good for us. So that's what we have there. Let me get this up. Whoops. So the Swan Nebula, again, is going to be one of those diffuse nebulas. This is where stars are born in the night sky. So these are giant clouds of hydrogen gas. and it's reflecting a bunch of light from all these different types of stars. And where stars are born in the night, basically how this process happens, just really quickly, is that all of this hydrogen gas starts to clump together like a snowball running down a snowy hill. And as it rolls down that snowy hill, it gets bigger and bigger. So that hydrogen gas ball is getting bigger and bigger itself until eventually it becomes so big and so strong that it can smash hydrogen atoms together. We call that thermonuclear fusion. In dealing with the nucleus of an atom. So we're smashing these hydrogen atoms together, and we're creating an immense amount of energy out of that, which is what is able to keep that star stable from collapsing in on itself via gravity. So that's pretty important, is that thermonuclear fusion. That's how we get energy from all the stars in the night sky. And they are born in nebulas like this one that we can see right there. So yeah, that's a pretty nice nebula. It looks like we can also do the Eagle Nebula next. It's right next door to the Swan Nebula, so we're going to go ahead and go there. So the Eagle Nebula, many of you guys might know this is kind of a famous nebula because the pillars of creation are located in it. It's one of the most famous Hubble images that have ever been taken by the Hubble Space Telescope, the pillars of creation. And the Eagle Nebula itself is also another massive star-forming region that we can see. So wait for the exposure to come in. It'll look very similar in color, but it'll look different itself as a nebula. We've got about a couple seconds left. The Eagle Nebula is my favorite. I look forward to it every single year just so I can look at it. And it's really awesome now that we have these plane wave telescopes to be able to look at it even better. All right, so we're gonna lessen the exposure a little bit. We're gonna change some stuff around just so we can get a little more of a clear image, not quite so bright. So we can start to see kind of in the center the pillars. There we go. That looks really good. So I'll kind of show you guys where the pillars are. I'll draw on my screen. So here's where the pillars are located, right in the center. You can kind of turn your head. You can see these nice dark clouds of gas that are coming up around the lighter areas around that. So those are giant clouds of gas that we can see. So let me get this out. There we go. And again, this is where stars are forming. So you can see that there's a lot of stars around them, especially right in the center. There's kind of a nice little cluster. So we can see lots of those stars coming in and around. That looks even better. This is a great image. So again, you can see those nice bright stacks of gas. Giant star forming region, definitely one of my favorites. If you haven't seen it yet, I would highly suggest go look at that Hubble image. It's really cool because the Hubble, being a telescope out in space, has less atmosphere to deal with, which means that it can get much greater pictures. And it's also able to take longer exposure time, which helps a lot as well with gathering more of that light and also that color. It's a great image to look at. So it looks like we have a request from Alan Fonseca. Can we see the Whirlpool Galaxy? Yes, so the Whirlpool Galaxy is also known as M51. So we'll go ahead and head over there. This is this one. It's pretty near the Conch as well, which if any of you guys have any telescopes at home, that's a good way to locate it, is off one of the stars of Ursa Major. So we're gonna wait for the image to change. We should be getting there fairly soon. Starting to get it. The next exposure will definitely help that out a little bit. So we can start to see, even right now, as we try to fix some of this stuff, is that we have two really bright galactic centers. So we have one up there and one down there. Now the Whirlpool Galaxy is so cool because what you're seeing here is two galaxies interacting with each other. They're not two separate galaxies separated thousands or millions of light years or even billions of light years away. They're really, really close to each other. We call this, nice, that looks like a great image. Now we can see those nice spiral arms right there. But we call this a galactic cannibalism type event. So that big galaxy is starting to eat that little galaxy slowly, bit by bit, and eventually over time that galaxy will be entirely consumed and it'll be just one big giant galaxy basically. So we call that galactic cannibalism. It's a super fun word. But we can see that right here by studying images like this. So that's how we know these types of things even happen. Because galactic cannibalism at a first hearing sounds really crazy. You're like, there's no way that's possible. But the Hubble and many other telescopes, including our own, can take images and say, hey, these galaxies are interacting, and one's actually eating another, which is pretty cool. Now, the thing about galactic cannibalism is that it's happening in our future, luckily in about 5 billion years, so we don't have to worry about it. But the Andromeda and the Milky Way are going to collide to become one giant super galaxy. The Milkomeda or the Milkdromeda, either way, it kind of goes both ways. It'll be the coolest candy bar, at least, but we'll just be one giant galaxy like that. So something similar like this will happen in our future. So this is pretty cool. Again, the whirlpool is one of my favorites to look at. So keep your requests coming in. There's many, many more galaxies to do. Let's go ahead and move to another nebula just to keep switching back and forth. Let's do the Dumbbell Nebula. Now, the Dumbbell Nebula is also one of my favorites. Last year, I got to take a really great picture of the Dumbbell Nebula, and I got Instagram famous because a little observatory posted it, and that was super cool. But the Dumbbell Nebula is a different type of nebula than we've seen from the other two, and I'll talk about that once we start to get the image up. So we're changing some of the exposure times again, just because we're going to be looking at something slightly different than a galaxy. So we're starting to get it in. I know you can already start to see the color on this, which is pretty cool. The Dumbbell Nebula is what we call a planetary nebula. So it's different than a diffuse nebula or a stellar nursery nebula, basically. A planetary nebula, despite what it sounds like, has nothing to do with planets. It is the death of a star similar in mass to our sun. So basically what this nebula is that this star, not massive enough to explode in a supernova, but small enough like our sun to kind of just push its gas away after the end of its lifetime. So our sun eventually will run out of fuel. It'll become a little bit unstable. Really, it just won't be able to hold all of that gas in anymore. So it'll kind of just push it away. And this is a remnant that we can see right here. So that's the remnant of a death of a star. Now, about the colors in this nebula, they are very apparent, which is super cool. We'll talk about a little bit about spectroscopy. So you might be wondering, how do we know about what all of these things out in the universe are made out of when we can't go there and actually take a sample and analyze it in one of our labs? So how we do this is with spectroscopy. So every single element in the periodic table has a sort of fingerprint light signature, which can tell us what it's made out of simply by looking at what type of light it emits or absorbs. So with this, around the edges, you can kind of see that nice orangey, reddish glow, and that's going to be a signifier for a lot of hydrogen and helium. Towards the center, we can start getting into some of those carbon elements as well. So when we look at this, we can say, hey, we know what the star was burning in its lifetime based off of what is left over of its gas that we can see in this nebula, which is really cool for being able to understand that. And also with these nebula, there's a tiny little white dwarf at the very center, which is the dead core of a star. So it looks like we have some more requests from Bill McDonald. How is M61 with its recent supernova? Let's try M61, it should be all right. We'll head over there. That sounds like a really fun one. Alrighty. So we're heading over to another galaxy. Like I said, the spring is just full of galaxies. We can see a lot of the galaxies in the Virgo supercluster. We can also see some in another local group pretty close to us. So there are just multitudes of galaxies in the night sky right now, which is super cool. So we're heading over to M61. Got a couple seconds left in our exposure time. There we go. Should be starting to get it soon. Nice. So we're starting to get it. You can see, it's a nice little, I think it's a barred spiral galaxy. It's a spiral galaxy at least, and we have a nice bright galactic center. Now it says with its recent supernova. I'm not entirely okay, there we go. Nice, that one. I wasn't sure which one it was, but a supernova is one of the brightest events that can happen in the universe. So it's when a star explodes. Now, if you can imagine imagine this star exploding, it's going to throw off an incredible amount of energy. So it's going to be very luminous when that happens. And astronomers can point their telescopes up at the night sky and see something rather unusual in these types of galaxies, or in our own night sky for that matter. So when they see something really bright that they hadn't seen perhaps a year or two before, they're like, hey, that's a supernova. That is a star literally exploding. So it has officially ended its life, which is pretty cool to see. They're spectacular events. They happen very rarely. So they're really, really cool to see and catch those in the moment. That was a great suggestion. Looks like we have another one. Someone asked for the Helix Nebula. Unfortunately, the Helix isn't quite up yet, so we'll have to wait for another date to be able to see that one. But hopefully at another time pretty soon. But keep your requests coming in. Albireo. Albireo, let's do Albireo. That one's a cool one. So Albireo is a binary star system. So we'll be looking at something completely different than the objects we have been looking at already. So this one's located pretty in the center of the summer triangle. So we're going to be heading there. It's rather low to the horizon at this point, but we can still find it pretty well. There we go. So here's Albireo again, a nice binary star system. So you can see that there are two different colored stars, which is really cool. So just like colors in nebulas, colors in stars can also kind of tell us what it's doing. So nice small blue stars are going to be really, really hot, and older red stars are going to be really, really cold. So it's kind of counterintuitive to what you might think, but blue means really hot and red means really cold. So there are two different temperature types of stars, two stars in different stages of their lifetime even, that are orbiting around each other. So they're gravitationally bound in this system that we can see right here. And Albireo is one of the most famous ones that you can look at. So while we're looking at this image, we're actually in video mode, so we're looking at it nice and live right now for sure. So you can kind of see them dancing around, like they're not quite flickering, but they're certainly moving in your screen. So why this is happening is because we live on a very habitable Earth that has an atmosphere. So an atmosphere will distort the light coming towards us. It'll kind of shake it around a little bit, which is what makes this image a little bit shaky itself. And that's part of the reason of why we put telescopes out in space, is to escape the atmosphere in its entirety. It's because we want some really nice clear images, especially of stars. And in order to do that, we kind of have to escape that atmosphere as well. So that's kind of how we do that. But for us right now, Albireo looks nice and pretty, and it's a great binary star system to look at. We have another one, M57 Ring Nebula. We should be able to get that in right. That one is in the constellation Lyra, pretty close to the star Vega, one of the brightest stars in the night sky, also part of the summer triangle. So we'll be moving to that one. The Ring Nebula is another planetary nebula, but it'll look pretty different than the Dumbbell Nebula. It'll look like a ring, hopefully. There we go. Ah, yes, nice and pretty in that nice ring shape. That's a great little image. So again, with that planetary nebula, those colors can tell us what that star was made out of during its lifetime, what it was burning through. So we can start to see some of those signatures of hydrogen and helium on the outskirts with that nice red color, getting in towards the center with some of that nice blue color. And even with this one, you can see the white dwarf pretty well, actually. It's going to be that star right in the center. So that white dwarf is actually what is illuminating some of this gas for us to see. So this, again, is the death of a star similar in mass to our sun. And one of the really cool things about doing this on the plane wave telescope is that if we were to look at these through a regular telescope, it would be really hard for us to gather that color because our eyes are really bad cameras, essentially. So we're able to have a better camera that can actually collect enough light to expose some of this color to us. So that's why it's really fun to start to see some of this stuff on an instrument like this instead of just looking at it in a traditional telescope. So we have another request from Tom Sarko. Can we get M84 and M86 in the same field of view? Let's take a look at that. Markarian's chain, we should be able to at least get one of them. 86 is definitely the brighter one. Let's see if we can try to do that. We can at least get one of them for sure, but it might take a little bit of playing around with some of the settings and such. So Markarian's chain, if you heard me mention that, is basically the center of the Virgo supercluster, that cluster of galaxies. That's going to be where a lot of the galaxies are centered, and we're actually part of that supercluster. So Markarian's chain is located pretty close to the constellation Virgo, and we're going to be able to start to see a bunch of these galaxies. All right, so it looks like we can at least see two. So we've got the nice bright one in the center, and it looks like we have a smaller one down to the left corner. I don't know if that is the M84 and M86 for both of them. So we can definitely see M86 nice and bright in the center right there. But we can get two galaxies. I'm not sure if the other one is the M84, but we got two galaxies in one field of view, so hopefully that's pretty cool. Looks like we have another request for M101. We should be able to do that one. Let's take a look at that. So we're going to be moving the telescope again. It's going to be moving pretty fast. We're going to be looking at, I believe, another galaxy, but we'll see. I don't have all of the Messier objects memorized because there are so many of them. So it's kind of fun to get to see, ooh, what are we looking at next? Alrighty, so we got there. It's a pinwheel. Okay, definitely know this one. This is a great galaxy to look at. M101 is definitely one to keep your eye out for in the night sky. And once it resolves itself, it'll be pretty apparent why. All right, let's take a look. So we're starting to get it. The next exposure should be able to get some of those spiral arms, and even better for us, we can even start to see some of that galactic center right in the center of the screen. So wait a little bit. We're taking a really long exposure for this one because in order to get enough detail to be able to see those nice dust lanes, those nice spiral arms, we're going to need to collect more light. So basically what that means is we're saying, hey, take this picture for a longer amount of time, and it's going to collect more light and allow us to create more detail in the image. So we're almost done with that one. Looks like we have about 3 seconds left. Let's take a look after this. That looks much better. So now you can see some of those arms. You can even start to see some of those dust lanes, and you can for sure start to make out that nice bright galactic center right here. So the pinwheel is a nice one to look at. And it's different than some of the other galaxies we have looked at tonight. We're going to do something, we're changing the settings real quick, so if you see something weird, we're just changing it up to try to get a nice image for you. Alrighty, take a look. Changing the range a bit. Alrighty. We're starting to get even more detail, and that looks pretty good. Nice. Sweet. Alrighty, that looks great. So again, with this one, it is a face-top view, so we can see it kind of like face down. And that's contrary to some of the other galaxies that we looked at, which were edge-on, so we could see it kind of in its like thin orientation. This one is kind of in its wide orientation. We're looking at it straight on, so we can see the extent of the actual galaxy. So let's see. Yes, let's look at M83 real quick. Let's pop over to that one. See what that looks like for us. So do M86, and then it looks like we have even more requests coming in, which is pretty awesome. Yes, M83, the southern pinwheel. Nice. So there are many pinwheel galaxies in the night sky, so it's a little bit confusing, but we're going to be looking at what we call the southern pinwheel galaxy, or the Coma pinwheel, I think. Or no, that's a different one. But it's probably going to be very similar in terms of what the pinwheel galaxy looks like. But let's take a look at what it looks like pretty soon. So yes, lots of pinwheel galaxies in the night sky. Very confusing sometimes when you're just trying to find a nice galaxy to look like. And astronomers are really bad at coming up with unique names, so they kind of just fall back on the same ones over and over again, which is kind of annoying sometimes. But this is a great galaxy. It is very, very bright, but we can see those arms really well. We can even start to see some of those dust lanes, which is fabulous. So this is a great one to look at. M83 was a great request. Nice. All right, so it looks like we have even more. Can we look at a galaxy which will look flat to us? And I believe M66 will work pretty well to that. So we're going to go ahead and move around. So keep this image in mind as we look at the next one and kind of just compare and how they look different to each other. So we're going to look at M66, which should be flat on galaxy. Let's take a look. Okay, actually, we're going to move to NGC 4565. This one should be a little bit better view for that flat-on look. Let's see. Sweet. There's so many galaxies in the night sky that sometimes it's hard to keep track which ones are like thin view, which ones are a flat view. So we just kind of have to navigate that, but we're going to get that image in. Nice. So we're starting to look at this one, and as the image starts to resolve itself, you can already start to see that it is very thin in how we're looking at it and how it's oriented itself. You can even start to see that nice like pancake shape of the galaxy. So you can see that galactic bulge, and right in the center you can see that nice dark lane in the middle, which is going to be the majority of that gas and dust that comprises of a galaxy. Nice. That looks super great. So we can see this flat on. So comparing this to the pinwheel where we were looking at it face down, where we could see the entirety of all of those spiral arms, this one we can mainly just see the galactic bulge, and this helps us really understand how thin galaxies really are, which is super cool. So galaxies can be thousands of light years across, but they'll be very, very they're not going to be very thick. Again, they're going to be like pancakes, which is pretty cool to us to be able to look at. Okay, so it looks like there's some more. So we have a request for M64, the Black Eye Galaxy. We'll take a look at that one. This is a really great one to look at, and this one's actually one of the only galaxies that are aptly named. It does kind of look like a black eye when we look at it, which will become apparent soon enough. There should be another galaxy. It'll be a slightly different orientation than the one we're looking at now, which will give us an even more clear picture of how galaxies look in the night sky to us. But this one is really cool to look at. It's also a nice and bright galaxy, which is helpful for us as well. So we're getting there soon. And if you guys have any objects that you would like to look at, start getting them in soon, because we're coming up on our mark of, we'll have to end the talk soon, unfortunately. So if you guys have any things you really, really want to look at, get them in the chat soon and we'd be happy to show you guys. All right, here's that Black Eye Galaxy. So that one, as you can see, it looks like an eye, which is super cool for us to see. So we can see that nice bright center. We can start to see a little bit of some of those arms coming in and around, but it's mainly kind of just, it kind of just like fades out from that nice bright center. We can see that really nice dust lane in the center as well, which is great. So when we study all these different types of galaxies, we can compile like all of the puzzles in a puzzle piece to how galaxies actually look like, how they form, how they interact, and just having all these different types of views can really help us understand them, which is why it's important to look at many different types of galaxies. So that was a great request. The Black Eye is pretty cool. Okay, so we have a request for the Lagoon Nebula. We should be able to get that one in, I believe. We'll take a look at that one. Sweet. So the Lagoon, again, is going to be a nebula, so we're taking a break from galaxies for a bit. The Lagoon Nebula is also a great one to look at. Hopefully. We'll hopefully be able to get it in. It is slightly close to the horizon, which might make it slightly hard for us to find, but we'll play around. We'll see what's going to happen. So again, this is all live imaging. We're doing this right on the fly for you guys. Should be able to get some of it in, hopefully. Let's see. Starting to get that in. We can already start to see some color, which is pretty cool. Alrighty. There we go. Waiting for that exposure time. Changing some of this up. So Lagoon Nebula is going to be pretty similar to the Swan Nebula and the Eagle Nebula. So it'll be a nice, bright, diffuse nebula, hopefully. Trying to get that image in. It might take a little bit more tweaking. I'm just trying to figure out if it's even going to be visible for us. Sometimes the telescope doesn't like when we get too close to the horizon, so it'll throw a fit sometimes. So we're going to try to get in for you guys, but if you guys have any questions, especially if you have any of those cool ideas of what globular cluster looks like, we'd be happy to hear, because it's super super awesome to me. I like to collect all of those things and tell all the guests. So that's pretty cool. So we're starting to get this in, hopefully. Sometimes we run into technical difficulties with this. So this is a telescope that is entirely run by a computer, which means that when something breaks or something goes wrong, it can be a little bit difficult to figure out what happened sometimes. So it's not as easy as a traditional telescope where you might be able to just like break it by hand or do something with your hands by yourself. So we're trying to figure this out. There's definitely a lot more intricacies with a computer-run telescope, but hopefully we'll get it up and running soon to finish off all of your guys' requests. So it looks like we have a question for the telescope in mount type. For the telescope, this is a 14-inch Planewave CDK, and I believe the mount is one of the Planewave mounts. I believe the mount and the telescope kind of are like of the same company. All right, so Sarah, our operator, says, I think we got to call it. So unfortunately, the mount is a 1350 for that person who's here out tonight. I'm sorry for all of you who are waiting to get some of those images in. If you guys keep them in mind, we'll have some more of these types of live streams in the next coming weeks. So keep an update on the social media pages to be able to see if it's weather dependent on that. Of course, we need clear skies to be able to do this. So take a look at our Instagram, our Twitter, and keep updated on YouTube here as well. Unfortunately, our telescope isn't working anymore, which we're sorry to have to call it a little bit early, but it happens sometimes. So if you guys have any last questions, feel free to let us know, but we'll fix it and we'll be able to get it up and running next time for you guys to be able to have some nice requests. We'll be able to look at more galaxies, more nebulas, and whatnot. So thank you guys all for coming in. And again, I'm sorry that we had to shut down a little bit early, but ask us any more questions, but don't forget to tune in to see what will happen next time. So thank you guys so much for joining us for a little bit, at least tonight. So trying to get this